Exercise 12.1, coordinate axis system and functions. Starting with some definitions here, the coordinate plane is made up of two number lines, one horizontal and one vertical, intersecting at a point called the origin, which is at the ordered pair 0, 0. The x-axis is the horizontal number line, and the y-axis is the vertical number line. The axes break the coordinate plane into four sections called quadrants, which are labeled with Roman numerals. So here's a coordinate plane with the four quadrants labeled. We go counterclockwise with Roman numerals, starting in the top right, quadrant 1, 2, 3, and 4. X-axis is the horizontal axis going left to right. The y-axis is the vertical axis going up and down. They intersect at this point in the middle called the origin. When we graph ordered pairs, we start at the origin, and the ordered pair gives us directions on how to get to a certain point in the coordinate plane. So when I'm looking at the coordinate plane here, starting at the origin, if I go to the right and I go up, that is positive in the x direction and positive in the y direction. So anytime both coordinates are positive, such as the coordinate 4, 3, we end up in quadrant 1. If I start at the origin and go to the left, that's negative in the x direction. And if I go up, positive in the y direction. So all ordered pairs in quadrant 2 will have a negative x coordinate and a positive y coordinate. Starting at the origin and going left and down. Well, if I go to the left, that's a negative x value. If I go down, it is a negative y value. So all ordered pairs in quadrant 3 will both be negative. And finally, the fourth quadrant, if I go to the right, it's positive in the x direction. Go down, negative in the y direction. All ordered pairs in quadrant 4 will have a positive x coordinate and a negative y coordinate. An ordered pair xy gives you the location of a point in the coordinate plane. The first number of the ordered pair is called the x coordinate. The second number in the ordered pair is called the y coordinate. So the first number tells you how far left or right to move along the x-axis. That's the x coordinate. Second number tells you how far up or down to move. That is the y coordinate. Plotting these 4 points in the coordinate plane, then tell which quadrant or axis the point lies. The ordered pair 3, negative 2. Starting at the origin, we go 1, 2, 3 units to the right, down 2 units. There's point A, and point A lies in quadrant 4. Point B, 0, negative 3. The 0 tells me to not move at all left or right. The negative 3 tells me to go down 3. There's point B, and point B lies on the y-axis. Point C, negative 5, 4. The negative 5 tells me to go 1, 2, 3, 4, 5 units to the left. The 4 units up. There's point C, and point C lies in quadrant 2. Last one, point D, negative 2, 0. The negative 2 tells me to move 2 units to the left. The 0, none up or down. There's point D, and point D lies on the x-axis. Moving on now to functions. A function is a relation in which every element of the domain is paired with exactly one element of the range. To better understand this definition, we need to understand what domain and range are. The domain is the set of all x values or inputs into a relation. The range is the set of all y values or outputs from a relation. If we know that a relation is a function, then we can write it in function notation. In function notation, f of x simply replaces y in our equation. So if I have that equation of a line, y equals 3x minus 4. Y equals 3x minus 4 is the graph of a line, which is a function. So I could also write that as f of x equals 3x minus 4. Does not change anything as far as what the equation is. Just understand that f of x is replacing y. Function notation does two things for us. It makes it easier for us to evaluate functions at specific values. If it's written in function notation, you want to evaluate f of 4, you would put 4 in every place you have x. Second thing it does is it guarantees that the relation that is given is a function. So in other words, you cannot write something in function notation if it is not a function. So focusing on this first definition, a function is a relation in which every element of the domain is paired with exactly one element of the range. So looking at this first example, determining whether or not this is a function. We have the domain on the left and the range on the right. A lot of students would look at this part right here and say this is not a function. This is a function. The reason it is a function, if you look back at that definition of a function, it says a function is a relation in which every element of the domain is paired with exactly one element of the range. So I need to look at each domain value and determine, is it paired with only one element of the range? 2 only goes to 0. 4 only goes to 3. 6 only goes to 3. 8 only goes to 5. Each domain element goes to only one range element. That is why this is a function. There's nothing in the definition of a function that says each domain value has to go to a unique element of the range. They could all go to 3, and this would still be a function. Second one, input. Remember, input is the same as domain, or the x values. Output is the same as the range, or the y values. In this case, this is not a function. The reason this is not a function is because the domain value of 2 has 2 different range values. 2 goes to 3 and it goes to 4. We cannot have a single domain value with 2 outputs. Function notation. If f of x equals 2x to the x power minus 3x, find f of 3. F of 3 means that 3 is replacing x. So every spot over here I have x's, I'm going to put in 3. So f of 3 equals 2 times 3 to the third minus 3 times 3. Follow order of operations, simplify this expression. We get 2 times 27. 3 cubed is 27. We have to multiply before we subtract. We end up with 54 minus 9. 54 minus 9 is 45. Second one, f of x equals 2x minus 9 to the 1 over x. Find f of negative 2. So now I'm going to put negative 2 in to this new expression every place that I have x. 2 times negative 2 minus 9 to the negative 1/2 power. Again, follow order of operations. We end up with negative 4 minus 1/3. Use your calculator to plug those in. So f of negative 2 then, negative 4 minus 1/3 is negative 13/3. Last one, composition of functions. When we have composition of functions, f of x is 3x plus 2. G of x equals x plus 2. Find f of g of x. When you have composition of functions, start with the inside function first. Okay, our inside function, f of g of x, all I am going to do is substitute x plus 2 in for g of x because that's what g of x is equal to. So I have f of x plus 2. Put x plus 2 in now into our f function. So just like up here, we put negative 2 in every place we had x. I put 3 in every place I had x. Here I'm going to put x plus 2 in every place that I have x. So I end up with 3 times x plus 2 plus 2. Distribute 3x plus 6. Add like terms, 3x plus 8. Last one here, graph each equation. When you graph linear equations, you can use whatever method you want. If you have a graphing calculator, you can plug it into your graphing calculator. If you don't, you can use slope-intercept form. Remember, slope-intercept form is y equals mx plus b. You can also just simply make an xy chart if you want to. Plug some values for x in, see what you get out for y, plot those points. You just have to be able to graph a line. So in this case, if we use slope-intercept form, the slope is 1, the number right in front of x. Y-intercept is the number being added or subtracted from x. In this case, nothing. We begin graphing then by putting a point on the y-intercept. Use our slope. Remember, a slope of 1 is the same as up 1 over 1. Follow that pattern for as many points as you need to. Connect those points. And there's your line. Letter B, f of x equals 2x minus 3. Remember, this is the same thing as y equals 2x minus 3. So again, we can identify the slope as 2. The y-intercept is negative 3. Put a point on the y-intercept at negative 3. Slope is 2. Remember, that's the same as 2 over 1. So a rise of 2, a run of 1. Again, continue that pattern for as many points as you need to. And there's your graph of that line.